I think we're live.
Perfect. I'm just waiting for the awesome. Muted. Okay.
You can see my screen, right?
Yep,
Cool.
perfect. So this will also be recorded. Um, I know a couple of the builders I spoke with were not able to make it, but
Are there any way for them to ask questions during the
yes,
live streaming?
yeah. So I will be moderating the comments as well.
Oh, okay.
Um,
So I don't have to like monitor or look at the questions anywhere,
no,
right?
no
Or
problem. I'll be handling that if you do get any questions. And if we get questions on Discord, I'll pass them along your way as well.
sure, let's do that.
Perfect.
Yeah.
So we may begin.
Okay, cool. Yeah, thanks a lot, everyone, for coming today to go through the workshop. So the purpose of this workshop is really to give you a high level overview of Meter, what we're doing, and what's the unique aspect about Meter. And also, I will walk you through a simple example in deploying smart contract on Meter and get it verified and how to interact with the contracts through our Explorer, things like that. So without further ado, let's get started. Um, yeah, so we started the Meter project from 2018. So when we started, the initial goal was actually to complete Satoshi's original vision to create sound money independent of the fiat system. Means have a long-term stable purchasing power rather than highly volatile. Uh, but as we go through the process, we realize we actually have to um, like change the consensus design and very bottom of the how the blockchain is architectured and how the low level things should be designed. So we come to the conclusion that why not just put in the state of the art consensus protocol as well and solve the scaling issues for Ethereum since we're at the consensus layer anyway. So that's how the project has started. Um, the starting point of the new perspective or new design for the blockchain is that through the observation that I mean, people are nowadays talking about like proof of work, proof of stake consensus, but in fact, neither are real consensus. Uh, Both of them are just Sybil resilience techniques. Sybil resilience means how do I uh, defend against like spammers, for example, denial of service attacks. Like people try to just launch arbitrary node on your network and try to attack the network. Uh, the Satoshi invented like proof of work. In fact, it's actually just an economic consensus rather than a traditional consensus talked about in the computer science way. So basically, because doing proof of work have economic cost that prevent like arbitrary attackers from attacking the network because uh, the belief is the highest amount of computation or work is going to be honest. So that's how the Bitcoin create that probability-based consensus. So the longer or the higher amount of work in a blockchain, the more likely that blockchain should be like honest and authentic. But in the traditional method, I mean, computer science world, consensus is actually about replicating state machines or like synchronized state machines across different nodes on the network. Basically, imagine each node have its own ledger, and the state of the ledger is actually a state machine. To make sure everyone has the same ledger at the end of the day is about synchronizing their state machines. For synchronizing state machines, there's actually efficient ways to do it. I mean, after the 70s. I mean, for example, the PBFT-based consensus was invented in 70s, but there hasn't been any changes for about like more than 20 years. I think only starting from 2018, we started seeing like new consensus protocols for like high performance, fast synchronization, synchronized state machines across a widely distributed network. So this is a computer science problem. So for Meter, after realize this, we actually divided the protocol into two aspects. There's the proof of work aspect and also a proof of stake aspect. We use the proof of work to create the economic consensus for the metastable token I mentioned earlier, the one trying to complete Satoshi's original vision. But we use proof of stake with another token called the Meter governance token to protect the ledger or synchronize the state machines. So at the end of the day, it's like a hybrid consensus. The proof of work side, we're just using a forked Bitcoin implementation. On the proof of stake, we right now on the Meter mainnet is state of the art hot 2 BFT consensus. This is for like maintaining all your account information, all the ledger, all the smart contract information. That ensures the network can be both like fast and fast finality, higher throughput, and also highly decentralized. So Meter is a full EVM compatible chain, but with instant finality. That means there's no reworks or forks on the network. Every block is finalized. And also a slightly different things compared to the traditional EVM blockchain is Meter blockchain is front running resistant, meaning we do not use the gas price to rank the transaction order. The network will charge like a minimum base fee, and that base fee can vary from time to time based on the congestion status of the network. But everyone will be charged the same way. Even you pay extra, it doesn't mean like your transaction will be ranked earlier than other transactions. So this will prevent a lot of front running scenarios. And also because in our network, every block is proposed by a different block proposal. Because we have a very decentralized network, currently we have more than 320 consensus validators, independent validators from the community. So imagine like each of them will propose a different block within like 1.6 to like 2 seconds intervals. So it's very difficult to control like majority of them in order to have a high probability of front-running attacks to the network. So that's how we implement the front-running resistance part. And also because we rewrote the entire stack, the code is much more efficient than traditional EVM implementation. So for example, in order to run one Meter validator node, you only need to have like 2 virtual CPUs, 8 gig of memory. Compared to a traditional Ethereum validator, typically requires 8 virtual CPU and 32 gig byte of memory. And if you have a high spec of the machines, you can achieve very high throughput in the network. Essentially, we're bounded by the Ethereum virtual machine speed. because the Ethereum virtual machine on the high level is a sequential implementation. Every transaction has to be processed sequentially after each other. So basically, it will saturate a single thread performance on one CPU. So on the high level, oh, another different thing about the meter regarding to when you program in the network is typical on the Ethereum network, there's a sequential nonce requirement, meaning like your nonce, when you send the transactions, there's a nonce. The nonce has to be like completely sequential. If you have jumps in the nonce, the transaction will not be executed. Meter, on the contrary, there's no strict nonce requirement. It will reject the transaction if it carries the same nonce and same like from, to, and amount and details of the transaction. However, when you interact with the network, you will notice the nonce returned by the RPC node, or like you see in MetaMask, as completely random. So that means you can actually, you don't have to follow the strict nonce requirement, and you can send multiple transactions to the network in the same time. So that's one of the like performance optimizations we have done to the traditional EVM implementation as well. And it doesn't impact backward compatibility to traditional Ethereum dApps either. Oh, so this just basically on the high levels compares the meter consensus with like Tendermint and Avalanche consensus. Compared to Tendermint, it's just more scalable, more resilient to network failures and attacks, and support a much more decentralized network. Avalanche is actually more a probabilistic protocol, very similar to Bitcoin's probabilistic approach. But we believe in the financial world and application chains, deterministic behavior is actually the most desired. That's why we're focusing more on the deterministic consensus for the blockchain. Everything else is actually in terms of robustness to the network failures or decentralizations were very comparable to the Avalanche consensus. So in order to start developing on the meter network, I would first share some important resources. I think, let me just switch the sharing a little bit. So yeah, one of the most important resource for starting is actually our developer doc site. So if you go to docs.meter.io and you scroll to introduction to developer documentation, so here is more like a one pager of all the important information you have to know if you are familiar with smart contract development already for EVM chains. So first of all, the things you probably care about the most is the RPC. So we have, for example, RPC, Foundation maintained RPC nodes for our testnet and for our mainnet. And these are the links for the block explorer. Basically, from the mainnet is scan.meter.io. And our testnet is called Warring Stake. That's why you have like the scan Warring Stake.meter.io. And also you can get the testnet fast faucet for some initial tokens to get you started. There are two important tokens in Meter network. MTR, which is a gas token. That's a metastable token created by proof of work. And the MTRG is the governance token for securing the network and launch proof of stake validators. And we have more MTRG liquidity on the network in various DeFi applications compared to MTR. But there's also ways that you can get gas on the network through cross-chain gas swap as well. So these are also like when you interact with the Meter mainnet, especially through like MetaMask and other Ethereum applications, in order to interact with MTRG, MTRG itself is actually a native token. However, in order for users or developers to interact with MTRG easily through MetaMask and other Ethereum applications, we created a ERC20 interface, a smart contract interface for MTRG. So these are the addresses for the MTRG interface on the network. There's also one for MTR, but this one is rarely used. Most people use WMTR on the mainnet and testnet. And obviously, you have other like contracts that are used for like a multi-call contract that's mentioned here. And in order for the developers to safely launch a smart contract application to the community, one of the important thing is you need to have the smart contract verified. So we use Sourcify. This is a Ethereum Foundation supported source code verification infrastructure to verify our smart contract. So there's two places you can get your smart contract verified. The first location is you can go to the contract page. For example, this is a smart contract, and you can go to the contract page to verify the smart contract and upload. I'll go through in the example later on what kind of file you have to upload. So you can upload here, or you can go to Sourcify directly, and you can verify the contract through their UI interface, and the database will synchronize each other. After, verifying either location will display the contract information properly on the Meter Explorer. And also, if you launch a smart contract application, a lot of times you need to manage, for example, treasuries or smart contract admin permissions. So that requires a multi-sig contract or multi-sig wallet. So here we have a multi-sig wallet implementation at save.meter.io. This is only available on the mainnet. It's a smart contract itself is basically signed by the Genosis Save team, and the UI is a direct fork from the Genosis Save as well. And you will have exactly the same experience as running the Save, and also the security, as the signing is managed by the Genosis team. We also have GraphNode available on the Meter testnet and mainnet if you're needing any like subgraphs. So these graph nodes are like for testing purpose, like the graph test and graph.meter.io. So you can, when you deploy your application, you can use these graph node for testing purpose. However, because security issues and reliability issues, when you launch on the mainnet and if you want to run a subgraph, we highly recommend you to use either run your own graph node or deploy the subgraph on our foundation hosted node. Feel free to reach out to us when you're at that state, when you're at that step. there are other like indexers and APIs available for meter mainnet and testnet. For example, there's CertWeb, Prevalent, Subquery. They are available. One of the important things for developers when you guys go to a new network is the bridges. So on Meter, there are two bridges available. The first one is the layer 0 bridge that connects to many blockchains, and it's actually a generic message passing protocol. So it requires you, the developer, to build proxies or like build their based on the layer 0's OFT standard for like a cross-chain ERC20 token or cross-chain NFT. There's also a Meter Passport bridge. This is implemented and maintained by a group of professional validators for the Meter network. It's a multi-sig implementation, very similar to layer 0. It supports both ERC20 and NFT transfers across different blockchains, and also generic message passing across blockchains as well. So in order to get your tokens either like listed on the Meter mainnet in our, for example, the official wallet, or on VolSwap, or listed on the Passport UI, you need to submit a pull request through this URL. So this GitHub link. And basically it's more about the token addresses, the logos, things like that. And depends on whether it needs a bridge interaction. So we can help you on adding the bridge support for that particular token. So in summary, like layer 0 is more like a completely permissionless messaging protocol. So you can add whatever you want by yourself. The Meter Passport is more like you have to get us involved. You have to like bridge certain tokens. We have to add it for you through the smart contract interface. And there are also like oracles for the network. There are currently there are band protocol, WinNet. We're also pushing PIS networks like feed for like a couple of tokens to the Meter mainnet and testnet as well. There's a Supra, and also I believe API 3 will be soon online. Yeah, so there are like a couple of things you have to pay attention to, like when you interacting with the Meter network through the RPC interface. You can list. I won't go through all the details here, but yeah, you can just read through them when you actually start programming. And now I think it will be beneficial for me to just go through a simple example for smart contract development. So it will be a simple ERC20 contract that I will deploy on the Meter block on the Meter testnet. So if you go to our GitHub Meter.io, there's a repo called token ERC20. So this is a prepackaged ERC20 smart contract with various implementations. Supports things like either a basic token, or you can add additional features like upgradability, like whether you support the gasless token or not, or even like OFT capabilities. So I would say it's a complete package of everything you need for any ERC20 tokens. So if we go to the example, so here, basically, I have a local directory. I believe I already check out the token ERC20. So if you look at this, so what you need to do is you can just look at the README. So basically, it gives you the steps on what need to be done. So first, you need to have a relatively new Node.js implementation. So the entire repo is developed using Node.js and Hardhat. Most of our development, and I think a lot of majority of the Ethereum developer space are using Hardhat. So we highly recommend using Hardhat as well for your development. And that will make a lot of things much easier, like for example, verified contract, things like that. I will show later. So you just have to, like, for example, do an npm install to get things initialized. Yeah, I already done this, so it's fairly quick. And then you can do npm run compile. So this will like compile all the Solidity contracts for you. It may take a couple of minutes here. And while we're waiting for this, I just want to show we actually have deployment script for you as well, prepackaged. So there's different scenarios. So now I will just try this one, deploy a basic token. So this is actually an interactive interface that will help you to specify all the details while you deploy the smart contracts. And yeah, this it takes a little bit of time because I'm running at on Windows with subsystem for Linux. It sometimes a little bit slow. Yeah. So first step is here you have to choose which network you want to deploy. So for example, here I choose Meter testnet 83. Oh, one thing is the developer for this install deployment script was from China, so he used a lot of Chinese in the interface. But you can just from the prompt here to have an idea of what it's asking for. So now it's asked for a private key for the deployment deployer address. So I will just use some like well-known keys, for example. So let's say I will use the famous 001 key. I put some MTR in that address already. So, oh, one thing is you need to put 0x for your private key in the front. So here I'd ask you to put in the gas price. So just this is the gas price the deployment script get from the RPC. And this is the deployer address based on the private key. So now the token name, demo, let's see. Token symbol, let's do demo as well. Initial, this is asking for the initial circulation. So based on weight. So I'll just put in like a big number. So basically it's deploying, that's the, here is the nonce. Okay, so the contract was deployed at this address. So if you go to the Meter Explorer, so you can see we just deployed this ERC20 token with some initial supplies. The next step is we obviously want the smart contract to be verified. So you can come to here to verify. Actually, let's do it through the Sourcify interface, which is has better UIs. So if you go to the address, I mean the directory for your build directory, you will see there's a token ERC20. So there's a directory called artifacts. If you go to that artifacts, there's a directory called build info. You just have to like zip this build info directory and upload it to Sourcify. So here, yeah. So let's upload the. So basically, this zip file contains all the source code information and metadata for the for the smart contract. And just now we deployed. Let me see which one was it. We deployed the ERC20 Minter Pulsar. Let's see. Yeah, we deployed this contract. So what we need to do is we use this address. And here just choose a testnet. And the backend is basically doing all the verification. As you can see, the verification was done successfully. So here, let's go back to the contract. So I believe, see, if you just switch to the contract tab, now it shows it's verified. And you can do like read and write to your MetaMask to interact with these like smart contract interfaces. And yeah, so we're done here for this demo. And I think now it's time to open up to see if there's any questions from the community. Annalisa.
Yes,
Okay, yeah, I think we can open up for questions if there are any.
sure.
Yeah.
Yeah. I'm in the chat. It looks like there's no questions so far. There's just a few GMs.
Okay.
Okay, we'll give it a couple moments. I'll ask the chat again.
Yeah. In the meantime, maybe let me go over like several slightly different tweaks when you interact with Meter compared to traditional EVM chains.
Sure.
First, like on the Meter network right now, if you want to send the Meter native token MTR or MTRG directly to a smart contract address, you will get failures. So we recommend you to, this is just like a tweak that we have in the network to prevent like people making mistakes by sending tokens to a wrong address. So you could use the ERC20 interface to send the token to the smart contract address. It will achieve the same thing. And also, every transaction on the Meter network requires the chain ID to clearly specified and signed. The legacy Ethereum style transaction, which doesn't require chain ID, is no longer supported. And the minimum gas price on Meter currently is 100 GWei, and the network doesn't order transactions by gas price. In the case that if the network is highly congested, by default, after 320 blocks, the transaction will be dropped, meaning that it will never be able to execute, even you send it again. So at that point, you just have to like send a new transaction, basically sign a new transaction and send it over. The sequential nonce difference I mentioned earlier already. Yeah, I guess that's it. Oh, in certain cases, if you want to like
have a
deploy
question.
your smart contract into exactly the same address, the deterministic address, there's two ways to do it. One is you specify the nonce specifically instead of relying on the nonce returned by the RPC node. The other way is there's something called deterministic deployment through smart contract. You can like look at the example here for that purpose. Yeah, so I guess we have a question here, right?
Yes, yes. Someone asked, where can I find a list of contracts deployed on Meter?
Actually, because the Explorer like doesn't really index have an index for list of all the contracts. So we don't really have that information available. But if you're interested in look at what are the applications already deployed on Meter, you can go to our ecosystem page. Yeah, meter.io ecosystem. So these are the smart contract applications that's already deployed on our network. And also, if you look at our mainnet Explorer, and just look at the transactions and then see like these are an Oracle transaction, for example. And you can see some of the frequently used contracts on the network.
I'll share that. I'll share both of those links.
So in my deck, maybe we can go through some of the additional things we have in the deck. We went through the RPC bridges, smart contract verification. Yeah, we also have a set of NFT APIs. If you're building like NFT related like marketplaces and need have a like API instead of running your own subgraph, you can reach out to us. We can share our API documentation. It's still under development, but get most of the required information you need. And in order to help users on board the network, there are several third-party gas applications. For example, these GasBot and GasZip allow you to swap a token or like the gas token in other networks to the Meter mainnet. And also we have a gasless swap that supports some of the tokens to swap from one to another without the initial MPR gas. For example, getting MTR from the MTRG token. In terms of developers, after you finish the hackathon, when you are ready to deploy on the Meter network and access to the community, we can provide various helps, including on the marketing side, we can help you to arrange AMAs, tweets from the official account, helping to create graphics. There's grants that based on TVL for initial user acquisition, liquidity support. There we also have a Telegram and Discord channel for developer support, if you have any questions. And yeah, these are some of the resources that are useful. So there are like ERC20 samples, NFT contract samples, and yeah, adding tokens to the bridge and wallet support. Yeah.
Don't have any questions in the chat.
Mm-hmm.
Oh, we do have another question. Is there currently a NFT marketplace on Meter?
Yeah, so there's a basic marketplace called it's the URL is nft.voltswap.finance. Basically, that's the under the Voltswap finance. But we're open. This is actually developed by the team for the community. Like we're actually open to like more sophisticated marketplace as well. And we'd love to help you guys.
Yeah.
help
Do you mind
develop it.
typing that in our Zoom chat and I could pass it around?
Oh, yeah, sure.
Because I think Amir said he found one but got a 404. I'm wondering if it's the same.
Oh, let me see. How do I?
Yeah, let me find our chat. So, here.
Can I use chat while in Zoom? Maybe I share it later.
Yeah,
in
you
the-
said but it was NFT.boat swap.
Yes. Oh, I found it.
Oh, bolt swap. Okay, here we go.
Yeah.
Okay, let
I think
me.
there was like an NFT store. I think it's probably like the one having problem. That marketplace, it was a multi-chain NFT marketplace, and that developer seemed to have stopped the project.
Oh, got it. Yep.
Yeah.
Okay, cool. Thank you. I sent that in the chat. Well, any other questions?
Yeah, I guess if there's no questions, wish everyone like good luck in the team formation and also developing for the hackathon. We're looking forward to see your submissions. In
Yeah.
the meantime, like feel free to reach out to us during the process. If you have any questions or have any concerns or have any collaboration proposals you want to like talk to the team, we're here to listen and work with you.
Absolutely. And we will be having a workshop on Tuesday, same time, to go into a more in-depth knowledge on Meter. So
Mhm.
thank you, Shahan.
Yeah,
And
thank
you,
you,
everyone, for
Annalisa.
tuning in.
Yeah, thank you everyone for your time and have a great rest of your day. Happy hacking.
Yes, happy hacking. All right, take care.
Bye.